In our time together today, we have one topic to talk about, and we're just going to talk about one thing today. But the thing we are going to talk about is potentially a little challenging. So I put this fun little slide here. What we're going to talk about next is challenging. But once you understand it, I think it's not really that big a deal, but you'll probably have to work with it a little bit before it does make sense to you. And what we're talking about is the topic of polymorphism, which is a really fancy word for what it is that you'll see us describe today. And it is a characteristic that you see in many different programming languages, of which ABAP is one example of this. So what I'm going to do is I'm going to give you a set of rules that at first will probably not make a lot of sense, and then we'll write some code to illustrate it and bounce back and forth between the code and the rules, and hopefully at that point you'll understand what's actually going on and see the utility of it. At first you're going to probably say, okay, I understand this, but why should I care? And then I'll show you why you should care, and then at that point we're done. You know, that's not like this is going to be a 5-hour discussion here. So here's the idea. Polymorphism shows up in the context of inheritance. So we're talking about a situation that would be relevant to us. Let's see if I can find some whiteboard markers here. When we have a hierarchy of classes. So you know, what we're talking about here is a scenario where we have a parent class and we have a child class. Now, everything I'm going to show you, we'll just keep it in the context of a parent and a child. But we could keep building this tree, a grandchild, and we could keep building this up. It still holds true. But what we will look at is just examples that keep it pretty simple, looking at the relationship between a parent and a singular child. So here's our first rule. A variable that is a reference to a superclass. So in other words, a variable that relates to a parent. A variable that is a reference to a superclass is assigned a subclass object at runtime using what's called the narrowing caste. So what I'm saying is I could create a variable, which I'm illustrating here by this dot. And this variable might be of type to relate to a parent. But what I can do, if I wanted to, is at runtime assign a child object to it. Now you might say, why would I want to create a variable that relates to a parent and then associate it with a child? Well, that's what I'm going to have to show you the utility of. But this is the concept of polymorphism. The technical description for what we're doing, we take a data object related to a parent and instead associate with a child is called the narrowing caste. So our first rule of thumb is I can create a variable that is a reference to a superclass and can assign it to a subclass. So let's illustrate this, and we're going to write some code here just as we go along here to illustrate this and build this up. And I hope that in so doing, this will make the most sense to you here. So I'm going to use the two classes that we created previously when we were looking at putting classes into the ABAP dictionary. So that way we don't have to write class definitions and all of that. We can just make reference to things that are in the ABAP dictionary. So here's what I'm going to do. I'm going to have a data statement, and I'm going to create a variable called parent, which is type ref2 my Z35 document class. Okay, so now remember, this is a data object, but it hasn't yet been filled with a class. I might this point before, I'm not sure. But in other programming languages, what we would call what we created there on line 8 is a pointer. And in fact, what I have done is I have created a pointer object, which I'll just illustrate by this dot. And the type of it is something that can now point to a parent, which is why I called it parent. And it's a type reference to a Z35 document. Well, then I'm going to do this, data, child, type, ref to ZN. Remember I had that weird naming thing with this, purchasing document. And those two types that are referenced there are things that we created previously in the ABAP dictionary. So I now have this child pointer that is capable of pointing at child objects, specifically our purchasing documents. Now, at this point, these are pointers that are, we would call them in other programming languages, null pointers, because I haven't actually created any objects. So let's do that. Let's go ahead and do create object, create object child. Okay, so now I have created a ZN35 purchasing document, and that now exists at this point. I'm using the default constructor just to keep this example really, really simple. And so just to illustrate this now, what I can do at this point is I could say child arrowhead, and we have a method in there called display doc, which simply writes out to the screen the information about the document, and so this is what we see. Here's our purchasing document, and I know that this in fact is the purchasing document because it has the vendor ID, the company code, and the delivery date, which remember are things that don't exist for a normal document. So nothing that we have done to this point is in any way new or different, okay? So let's go back to what the slide a moment ago said. Let's read it one more time, and then we'll actually do it in our code. A variable that is a reference to a superclass can be assigned a subclass object at runtime using a narrowing caste. So I can do this. I can say parent equals child. So I have now taken pointed to, which is the only document that's been created at this point, this purchasing document, and I have now essentially, I now have this child variable, which is a pointer at it, and I have this parent variable. They're both pointing to the same object. So here's my question. What happens if I do this? Now let's remember that in our particular case, the display doc method of the parent calls for the system to write out what we saw at the beginning of this. I'm going to comment this out for a moment here. But the display doc method for a purchasing document shows the document number, the date, the type, but then it adds the vendor ID, the company code, and the delivery date. But the normal document, the parent, only shows those first things. So the question is, what happens when I use my parent class reference object and call the display doc method on it? What's going to happen here? Well, let's see what happens here. And what I'm going to do, just to keep this nice and easy for us to see, I'm going to put an underline between these two. The first time I'm calling this, I'm calling it with the child. The second time I'm calling it with the parent.
Is there a reason why you didn't create the object? Is that what
I just haven't needed to at this point. I could, but we would just throw it away. Notice the difference, which is to say, notice that there's not a difference. So even though I put the child into a parent box, even though I used a parent reference data object to refer to it, when I called display doc, I got the functionality of the child's overridden method. Because remember, that's what we did. We overrode the display doc method in the child. What I have just illustrated to you here is the concept of polymorphism. So the rule here is, because the subclass, because the child has all the methods and attributes of the parent, you're not going to see anything in the hierarchy here that it doesn't understand what it is. In other words, if the parent defines a method called, M1, that M1 method is going to be inherited by all of the children further down the inheritance tree. So anytime I point to any of these objects and I say, give me method M1, it's going to say, okay, I've got an M1 method. I can do that. That's not a problem. But the magic of this is, if you will, the thing that makes this so interesting is the idea that, because these things are available through inheritance, when the method is invoked, if the method has been redefined, you get the redefined version. So I could create an M1 method in the parent class, and I could override that in the child, and then I could further override that in the grandchild. And I could take that object and at runtime associate it with a variable of type parent, and when I call method M1, I'm going to get the most specific version based on the kind of underlying object it is. So the system basically, even though I've taken a child and put it in a parent box, the system still knows, oh, that's a child class, and we have a redefined method. This is polymorphism, okay? Now this is where I said, okay, first we've got to make sure we understand this, but then after you understand it, you might be inclined to say, why should I care? What's the big deal about this? And I'll get to that here in just a moment. Let me throw another couple of rules at you here. If I create a method only in the child class, brand new method, so the parent doesn't have it, but the child does, and I try to call that method, that I can't do, because the parent reference object doesn't know about that method. Okay, so let me explain that a little bit further, and let's go into the ABAP dictionary, because I did make a change to something that you have not yet seen. So if I go into SE24, that's our class builder here, and we'll look at, first of all, Z35 document. Whoops. Z35 document display. Okay, so here's my method: set doc number, set date, and display doc along with the constructor. Everybody that follows this in the family tree will know about those three methods, not counting the constructor. So I'll leave this up, and I'll open another instance of the class browser. And this time we will open ZN35 purchasing document. So notice here, I have redefined the set date method. That's why set date looks a little bit different color blue there. But then if you look really closely, you'll see that I've added a new method called, surprisingly enough, new method. Okay, which just is going to print something on the screen. So what has happened here, and I think somehow I had two markers, one of which worked and one of which didn't, and I keep trying to write with the one that did. So if we go back, just to put on the whiteboard what we're seeing here, we have a method here in the parent called set doc number, set doc number. We have a method called setDate, and we have a method called displayDoc. So everyone that's a child of parent knows about those three methods. It may redefine them, but it has them. That's part of what we get through inheritance. Well, when we added the purchasing document, you notice those methods are there, plus I now have a newly defined method called new method. New method. So if we jump ahead and say the grandchild is going to know about all four of these through inheritance. But it only works as we go down the tree in this fashion. The parent class doesn't know anything about new method because that doesn't exist in the context of the parent. So what does that mean? Let's go back to our code here. And I'm just going to, I'll pop up another underline just so we can keep this straight. And I'm going to do this. I'm going to do child, arrowhead, and the name of my method is new method. New method. Okay? Now the child is a pointer to this data object right here. It's of type reference to ZN35 purchasing document. So when I run this, in fact, we will see, hi, I'm a new method, which is what the new method prints out on the screen, okay? Not very advanced code there, just one write statement in that thing. But what is going to happen if I do parent new method? What do you think is going to happen? Okay, so you're suggesting that it might not compile, okay? And why would it not compile? The parent doesn't know about new method here. Well, in ABAP, we don't really talk about compile or not compile, but we can do a syntax check, and we can see that we get a syntax error here. Method, new method is unknown, okay? So you can see, both parent and child are pointing at the same thing, as illustrated by the fact that we get the same output on line 13 and line 18. But that only works because both the parent and child know the displayDoc method because of inheritance. And when displayDoc is called, I get the one that's most specific for the kind of object I am, which in this case is the purchasing document. But when I try and call a method that is not in the inheritance chain, as we think about looking at it working upward, that's no good, okay? This is polymorphism. Now, let's go back to, let me pause for a second and see, anybody have any questions about this? All right, well, there's an obvious question at this point, which is, this is cool, why should I care? What does this do for me? Does it do anything really, really useful? And the answer to that is yes. You're not going to use it in every program, but there are several instances where this could be very, very useful. Most notably, I can create things like an internal table and base that on the superclass and then put any of the superclass or the children in that internal table. So what I'm saying is I could have a table of parent and put parent objects in there and child objects in there and grandchild objects in there, and it'll all work just fine. Or in my example, I could put documents in it, I could put purchasing documents in it. But the key is I can only call the methods or only use the things that are part of the inheritance chain. All right? So let's look at this and see the utility of it. So I have some code here that I'm going to just clean up. because we don't need it anymore. So let's go back to, I've created an object child, and I'll do this. I'll create an object parent, okay? And just to make sure we're all on the same page here, if I do parent display doc, and I'll put an underline underneath it, and then I'll do child display doc. I get this, okay? We can see at the top, I get just 3 lines of output because that's a general document, and then for the purchasing document, I get 6 lines. All right, so let's illustrate the utility of this. I'm going to do a data statement here, data, and I'll just call this my table. And we haven't actually done this before, but I think you'll see this is really easy. Type standard table of, and you know how normally we would put here like type standard table of spfly or things like that? I can instead do type standard table of ref to Z35 documents. Now, in other programming languages, we might call this an array of pointers or something similar to that. ABAP makes this a whole lot easier, but conceptually, I can now create a collection. But here's the point of this now. I can put in my table anything in this chain of hierarchy. So I could do this. Append parent to my table. Append child to my table. Let's create some more here. Data, parent here. I'm gonna cheat a little. I'm gonna take these 2 lines and I'm gonna put them here, and I'm gonna say parent to child to parent to, and then I'm going to append these guys. But then just to illustrate that, well, let's just keep it like this. I think this is, so I have now put 4 things in this table, which I hope we would all agree, some of them are child objects and some of them are parent objects. So let's do one last thing. Loop at my table into, and I'm going to use our dynamic data creation, which by the way, some of you are using with great success and some of you are not, and having to write a whole lot more code as a result. I would really encourage you to try and get on board with the dynamic data creation, because I can just do this and I now have a work area that matches that structure. And so I loop at this, and I'll just do for the object that I have just pulled off, WA display doc, and then uline, and then I'm going to end the loop. And then just to make sure that all the output I have comes from my loop here, I'm going to comment out these other lines here. So my only output takes place inside of this loop. So if you think about what we just did here, we've created 4 different objects, and I put a parent into my table, then I put a child, then I put another child, and then I put a parent. Or actually I put parent, child, in that order, and appended it to the table. So now when I traverse the table, I have to fix the fact that I put an S on my data type. When I traverse the table, you'll see that the appropriate version of display doc was called. So think about this in a real world system. We might have a hierarchy of documents where we have 70 different documents that are all part of this chain of hierarchy. And every one of those documents defines its own display doc. Well, what I can do is I can create an aggregate data structure, such as an internal table, and base it on the root node, and then put any of the children in there that I want to, And when I call the appropriate method, it works. And it works on the most specific version, which would mean if there was a grandchild object in there, it would call the display document object of that, I don't know, credit memo. And for a debit memo, it would call its version of it. And for a purchasing document, it would call its version of it. And so although our code to illustrate this is very, very simple, the concept here is very, very powerful. Polymorphism allows us to do this. Any questions about that? So I'll go ahead and tell you, you're going to write a homework program. And I think I made reference to this before. Your homework program is, actually, what did you guys do for your, you did one recently with, was it train cars? Yeah, your next homework assignment is going to involve taking that train cars example and implementing what we did here, creating a train of train cars, of different types of train cars, and then just writing a loop that'll traverse through the train and print the information. But the information you're going to see will be slightly different depending upon the particular train car at that particular loop iteration. So it seems a little weird, but it's actually, I think, once you see it in action, it makes good sense. Now keep in mind, in my loop, I could not have called new method because the parent doesn't know about new method. So I have to stick with those methods that are known by everyone in the inheritance chain, which would be setDoc, setDate, and displayDoc. But not to overcomplicate this, if I created a table based on child, based on my illustration here on the whiteboard, and then put in it some child and some grandchild, I could call new method there because both the child and the grandchild know about new method. What you can't do is you can't put yourself in a situation where the underlying object that has been created doesn't know about some of the methods. So what's really happening here is you have a child object masquerading as a parent. It's like they dressed up as a parent for Halloween. But somebody looks at that and says, oh, you're dressed up like a parent, but I know you really are a child. And so it uses the data and it uses the methodology that have been defined for the child. Any questions about this?
Yeah, for what we did in class today, we used the data dictionary objects that we created. So will we need to go through there and do that for the train?
As long as you have an inheritance chain defined in your program, it works. I just use the data dictionary ones for the sake of ease, but it works just fine if your classes are defined hierarchically apart from that. And we already did this. So if a method is defined to take in a reference to a superclass data object, the subclass data object can be used. So what we just did is technically called narrowing caste, okay? You don't necessarily need to, that's just the term to describe when you take a child object and use a parent reference object to point to it. You can go the other direction and do what is called a widening caste. But this is only used in a very specific situation. So let me give you some definition here and then we'll talk about this. A variable that is a reference to a subclass. So a variable that is essentially pointing at a child can be assigned a superclass object at runtime. So it can be pointed at a parent. When we do that, this is called a widening caste. But what we are doing in this situation is potentially problematic because this reference object, this pointer, if you will, thinks it's pointing at a child, it's really pointing at a parent, and now we have potential confusion as to which method is going to be invoked. There's really only one time that you do this, and I like to think of it like, I don't know if any of you drink coffee is where you see this most typically, and you're probably familiar with instant coffee or freeze-dried coffee, where they take coffee and they reduce it to these little crystals, and then the idea is, they started with coffee, and then they freeze-dried it, and then you add water to turn it back into coffee, okay? What I can use a widening cast for is to put something back once I've cast it the other direction, okay? So this is typically used when a narrowing cast was previously used and you wish to restore the object back to its true identity. Okay, so what in the world does that mean? Let me show you an example of this. All right, so I'm going to go back here, and I'm going to take this and get rid of all this other stuff that we don't need and take this back to it in just its most simple form. All right, so I have a parent object and a child object. And I have pointers, variables that reference parent and child. So what we did a moment ago is we said parent equals child. And we saw that worked fine because when I did parent display doc, I actually got the version of display doc for the child, okay? This is what we did a second ago. I'm just recapping this. All right, so now the question of this. Suppose, because parent is, suppose I wanted to do this. Child equals parent. So forget about this. Suppose I wanted to do this instead. Child equals parent. So now what I've got is I'm trying to take a parent object and masquerade it as a child. So now instead of having a child that's dressed up as a parent for Halloween, I have a parent who is dressed up as a child for Halloween. So what's going to happen here if I try and do this? Well, no good. The error message there at the bottom, if you can't read it, says the type of parent cannot be converted to the type of child. So I can go one direction but not the other using the equal sign. So basically this is saying this looks like something that you really shouldn't do. You really should not be putting a parent in a child box because the parent object doesn't know anything about new method. So what's going to happen if you try and say child new method? It's not going to know what to do, and now you have a broken program as a result. So this is going to want you to do this. But suppose before we had done this, suppose we had done parent equals child, which we know is good. We know that's valid. So we did this on purpose, and we finish whatever it is we did here. This is where we do stuff. Okay, so we might have some code here where we do a bunch of stuff, and now we want to put everything back to the way it was. So I trust you understand that what happens now on line 19 is basically the inverse of what happened on line 14. I want to copy it back to where it was, but we already established the system's not going to let me do that. So how do I put it back to the way it was? It's a very rare thing for me to ever need to do, but ABAP does want to give me the ability to restore an object back to its true identity. The syntax for this is we use a move statement with what I think is the weirdest operator that ABAP offers us, the question mark 2, which to me looks like even the code is saying, do you really know what you are doing here? Because, and that, looks like I made a typo on the slide, but I didn't. That's the actual code. So if I want to move this back to the way it was before, and you always have to be careful about this because what goes where on the line of code flips around. So what I'm actually trying to do on line 19 but couldn't was this: move parent question mark 2 child. And so while it won't let me use the equal sign for doing this, it will take line 21. It will work. And so now parent is back to being a parent again. And everything is restored to the way it was. So I've got to comment out this guy because it's going to give me a syntax error, but as you see, nothing at all wrong with this now. And so in fact now, if I call parent, whoops, display doc, it's going to work fine. And admittedly, this gets a little bit confusing. We got to look at our whole sequence of code here to try and make sure we understand what's going on. And I seem to have lost my scroll bar on my, all right, so I created a child object, I created a parent object, I stuffed the child in a parent box, and then I did stuff on line 16, I'm not sure what, but then I want to put it back. So on line 21, I put the child, I moved the parent back into the child box, and then this should say child display doc here, 23. So that's the other side of this. This is like the metaphor I used a second ago. It's like reconstituting freeze-dried coffee. All I'm doing is I'm undoing what I did a moment ago with my narrowing cast. How often do you use this in programming? I use it when I'm illustrating this slide. That's probably the last time I will ever use it. I mean, I'm just showing it to you for the sake of completeness, but we really don't have to use it. You know, I didn't have to use this before when I put all those different kinds of documents in my table, and you really won't have to use it in the code that you write because it's not something that's necessary except in a very specialized situation. Questions? Now I have this slide right here that you will see in your homework that's just an illustration of what we did. But quite frankly, if you understand, reading this might make you confused. Polymorphism is kind of one of those things that if you think about it too hard, you wind up confusing yourself. So get to a point at which you're comfortable with it, write your homework, make sure you know how to work with it, and then don't spend a lot more time thinking about it. I know all of you think about ABAP all the time, but this is something, the more you think about it, it's kind of like thinking about recursion. Have you ever done that before? And the more you think about recursion, the more your brain starts to hurt, and you feel like you don't understand it anymore, even though you do, and it's because you just thought about it too much, and now you're broken your brain. Don't do that with this, okay? So I'm not going to give you a homework program today. I'll give you your next homework program on Thursday. I pretty much told you what it already is, but don't start working on it because I'll give you some specific instructions, but I'll give that to you on Thursday. Thursday we'll talk about another topic. I think I'm going to change things up a little bit, and on Thursday talk about ALV grids, and that's what we'll do on Thursday, and that'll let me give us a homework program related to ALV grids, which will probably wind up being an optional program. And so that is what you will get on Thursday when we get together. Yes, sir? I do not. But the way the optional program will work is I will grade it out of, I can't grade it out of 0 points possible because then D2L tries to divide by 0, which you can't do. So I'll grade it out of 1 point possible. So you can get a 15 out of 1 or a 20 out of 1, which basically just adds points to the numerator, which will help you raise your grade overall. So that's the way I do that instead of just dropping a quiz grade. All right? Questions? All right, well, this is where we will stop for today. Have a good afternoon, everyone. If you didn't sign in, make sure you do that before you